Alright, we're going to look at vectors and multiplying vectors. Okay, a vector is basically a diagonal line. Majority of the time it's a diagonal line. Okay, and the direction of the line is dependent and given by the numbers in those brackets there. Okay, so vectors give direction, they give you size. The direction is the angle, the size is the length of the line. So if we start at any point x, and that vector tells us that we're going to go 3 squares to the right and then 2 squares up. Okay, and that diagonal line is then our vector. So the angle is the direction and the length of it is the size. If we put 2 vector A together, then our line is going to be double the length. Okay, and that's essentially what we're looking for now. So our first step is to just multiply the vector. We have the vector A, which has given us 3 and 2. Therefore the vector 2A is us scaling up vector A. Right? So whatever vector is, we're going to scale it up by the number 2. And just like anything, when we scale it, we're multiplying. So 2A is going to be 2 times by our vector, which is 3, 2, which is going to be 6 and 4. Okay. The video is a little bit laggy, which is a bit horrible, so we'll work with it. What does this mean? So we've got a vector. What does this mean? So we've got the vector A. We know the vector is the green line, well, one of them anyway. Well, the vector 2A is going to be 2 of the green lines together. So we'll go through that again. So the vector A tells us we're going 3 squares to the right because the 3 is positive, and then 2 squares up because the 2 is positive. X then Y, and that's our vector A, the diagonal line. Now the vector 2A is going to be double that, so we're going to go 6 across, and then we're going to go 4 up. Okay, so when we compare, we can see that the vector 2A is double the vector A, and that is what we're doing. We're trying to multiply vectors to get a bigger vector. Same vector, same direction, just a bigger size. Okay. Same vector, same direction, just a bigger size of the line. That's what the vector 2A tells us when we compare it to A.